Welcome to the Deep Dive. Today we're diving into the fascinating world of wind energy. We've got this article titled, Student Cracks Century-Old Math Problem.
And it's a pretty big deal.
Oh, it's huge.
Yeah.
This deep dive is all about how one grad student might have just, revolutionized the field.
Exactly.
The article focuses on Divya Tyagi.
Yeah.
She was studying at Penn State, and she just made this groundbreaking discovery about how we understand wind turbine aerodynamics.
Mm-hmm.
It all comes down to cracking this math problem.
Right.
That's been stumping researchers for over a century.
A long time.
Yeah. What's really cool is that her work could lead to a massive boost in wind energy efficiency.
Yeah, to really get Tyagi's work, we kind of have to go back in time a bit.
Okay.
Back to the early 20th century, to this guy, Hermann Glauert. He was a British aerodynamicist.
Okay, so paint a picture for us. Who was this guy? And why is his work so important to all of this?
Well, Glauert, he developed what's called the optimum rotor disk solution. It basically set the foundation for understanding how wind turbines take wind energy and turn it into power.
Oh, wow.
Yeah, his work was the bedrock of wind turbine design.
So Glauert's findings were essentially wind turbine 1.0.
You could say that.
It sounds like he was way ahead of his time.
He was. But, like many pioneers, his work had some limitations based on the tools and the understanding at the time. And so while groundbreaking, his theory really focused on maximizing power.
Okay.
And later researchers realized that to design truly efficient and durable turbines, they needed a model that factored in all these complex forces acting on the blades.
Yeah, that makes sense.
Yeah.
So it's not just about, squeezing out every little bit of power. You also need to consider how the turbine's actually going to hold up under stress.
Right, exactly.
So is that where Divya Tyagi comes in?
Exactly. Tyagi's research kind of picked up where Glauert left off, and she used this pretty complex mathematical tool called calculus of variations.
Okay. I'll admit. Calculus of variations sounds a little intimidating.
Yeah, it's pretty high-level stuff.
Can you break it down for us? How did Tyagi use this to, move our understanding of wind turbines forward?
Okay. Think of it like this.
Okay.
Glauert's model was kind of like drawing straight line between 2 points. It was a good starting point, but in reality, the path is much more complex.
Right.
So Tyagi, using this calculus of variations, was able to consider all the curves and bumps and detours along the way.
Okay.
So her model didn't just look at power, it also considered things like thrust, which is that force pushing the turbine forward, and the bending moment, which is how much the blades actually bend under pressure.
Ah, okay. So it's all about creating a more realistic model that really takes into account the real-world conditions these turbines are facing out there.
Right.
I'm starting to see how this could lead to, some major breakthroughs.
Yeah.
But what were, the real aha moments in her research?
Yeah.
What did she specifically discover that got everyone so excited?
Well, there are a few key things that really stand out.
Okay.
First, while her method is revolutionary, it also kind of simplifies the really complex math involved.
Okay.
And it actually recovers Glauert's original findings.
Oh, wow.
So it shows this beautiful continuity in scientific thought.
So it's not like she threw out the old textbook,
No, not at all.
She just built on it, expanded it. That's really impressive.
Yeah.
What else did she uncover?
Well, the old model, it predicted that some of these forces, thrust and bending moment, would pretty much disappear at low wind speeds.
Oh, really?
Yeah. But Tyagi's research showed that that's just not true.
So the old model was basically saying these forces just poof, vanished.
Well, not quite vanished. It's
Okay.
just that it didn't really, explain what was happening with those forces at those lower speeds. And what Tyagi found is that they actually still have specific values, even at low wind speeds. So this gives us a much more accurate and detailed picture of how turbines operate across all wind conditions.
Okay. So she's filling in those knowledge gaps.
Exactly.
And giving us a much more realistic understanding of these powerful machines. This is getting really interesting, but how does all this translate into real world impact?
Well, that's where it gets really exciting. Even a tiny improvement, like a 1% increase in efficiency, can make a huge difference when you're talking about these, massive wind turbines. We're talking about potentially generating enough extra energy to power hundreds of homes.
Wow. A 1% increase could have that much of an effect.
Yeah.
That's incredible. And if I remember correctly, the article also mentioned that her work could lead to like more durable turbines.
Yes, absolutely.
Okay, I'm starting to see how this could be a complete game changer for wind energy.
Yeah.
But tell me more about this improved durability.
Okay.
How does that actually work?
Well, by understanding these forces better, more accurately, engineers can design turbines that can withstand harsher conditions.
Okay.
And last much longer. So that means fewer breakdowns, less maintenance, and ultimately lower costs.
So increased efficiency, greater durability, and lower costs. This really does have the potential to revolutionize the wind energy industry.
It does.
It really does. But before we get too far ahead of ourselves, let's talk about the recognition that Divya Tyagi received for this groundbreaking work.
Sure.
The article mentions some pretty impressive accolades, right?
Yeah, she got the prestigious Anthony E. Walk Award.
Oh, wow.
Which recognizes the best thesis amongst her aerospace engineering peers.
Wow. Okay, so it's not just us who are impressed.
Right.
Her work is getting serious recognition in the academic world.
Yeah.
And to top it off, her research was published in Wind Energy Science.
Right.
Which is a highly respected journal in the field.
Exactly. So this means her findings are now part of this bigger scientific conversation.
Right. It might influence future research and practical applications. And it's really cool to see how scientific knowledge builds upon itself like this.
So we've got a brilliant student tackling this century-old problem, comes up with a groundbreaking solution, and potentially revolutionizing a world of wind energy. It's truly inspiring to see how one person's dedication and their fresh perspective can make such a massive impact.
It really is. And what's even more fascinating are the wider implications of Tyagi's work.
Mm-hmm.
It's not just about individual turbines. It's about the future of sustainable energy as a whole.
Okay. I'm ready to dive even deeper.
Okay.
You've definitely piqued my curiosity.
Okay.
Tell me more about these wider implications.
Well, let's think about the impact on large-scale wind farms. Remember those massive turbines we were talking about?
Yes, those behemoths. That can sweep an area larger than a football field.
Exactly. It's mind-boggling, the scale.
Yeah.
And that's where even that 1% improvement in efficiency becomes a really significant factor. Right. You mentioned that a 1% increase could power hundreds of homes.
Yeah.
Can you give us a more concrete picture of what that actually means?
Okay, sure. So let's break it down. A single large wind turbine,
Okay.
with that 1% efficiency boost from Tyagi's research, could generate enough additional electricity to power roughly 200 homes.
Oh!
For an entire year.
That's amazing. But what about the bigger picture?
Okay.
How does this translate to wind farms and the overall energy landscape?
Well, imagine a wind farm with, let's say, 50 of those massive turbines.
Okay.
With that same 1% increase in efficiency, we're talking about powering an additional 10,000 homes annually.
Okay, now we're talking about some serious impact.
Yeah.
That could potentially power a whole town.
Yeah.
Or even a small city.
Yeah.
But it's not just about the number of homes, is it?
Right.
There's also cost savings to consider, right?
Absolutely. And this is where the long-term implications really come into play.
Okay, this is all starting to come together. Tell me more about these cost savings.
Okay. So the increased energy output directly translates into lower costs for consumers. And, when we talk about renewable energy, we're not just talking about, environmental benefits, we're also talking about economic benefits.
So this is a win-win situation.
It is.
Both for the planet and for people's wallets. It sounds like Tyagi's research could be a major driver in making wind energy even more competitive with, traditional fossil fuels.
Yeah, absolutely. And that's just one part of it. Let's not forget about the increased durability we talked about earlier.
Right. That longer lifespan of the turbines is a game changer as well.
Yeah.
Can you elaborate on why that's so crucial? What specific benefits does it offer?
Well, think about it this way. When turbines last longer,
Okay.
they need less maintenance,
Yeah.
which means fewer repairs and replacements.
Right.
And this translates into significant savings, over the lifetime of the turbine,
Okay.
which further reduces the overall cost of wind energy.
Right. So it's like a ripple effect. The initial investment in better technology leads to all these, cascading benefits.
Exactly.
From increased energy output and reduced maintenance costs to a more stable and reliable energy grid.
Right.
This is all starting to paint a very compelling picture for the future of wind energy.
It is. And there's another layer to this that I think is really fascinating.
Okay, you got me hooked. Tell me more.
Tyagi's model, it opens up the possibility of like customizing turbine designs to suit specific locations. Imagine turbines that are tailored for like coastal areas or mountainous regions or even offshore environments.
So you mean like building turbines that are optimized for the unique wind conditions of that particular area?
Exactly. Previously, engineers had to rely on these like more generalized models, which limited the efficiency and effectiveness in different environments. But with Tyagi's work, we can actually factor in, specific wind patterns, turbulence levels, all these other, environmental factors.
So we're moving away from that like one-size-fits-all approach.
Right.
And towards a more like tailored solution that maximizes energy output in any given location.
Exactly.
That's incredible. It sounds like we're moving into an era of like haute couture wind turbines.
I love that.
Yeah.
Yeah.
That's great. And this level of customization has the potential to like make wind energy viable in so many more places around the world.
Exactly.
It's really expanding its potential as like a global energy source.
Mm-hmm.
I'm seeing the ripple effects now. This isn't just about like individual turbines. It's about transforming the entire wind energy landscape.
Right.
And making it a dominant force in the global energy market.
Yeah, it's a paradigm shift.
Yeah.
And to think this all started with one grad student's dedication to refining this century-old theory.
It really makes you wonder, what other hidden gems are out there just waiting for someone to ask the right questions.
Right. Sometimes the most groundbreaking discoveries come from a place of pure curiosity and a willingness to challenge those established norms. And in Tyagi's case, it led to this scientific breakthrough that has the potential to change the world.
This has been an incredibly eye-opening deep dive so far. We've explored the complexities of wind turbine dynamics, witnessed the power of innovative thinking, and glimpsed a future where renewable energy really takes center stage.
Yeah.
And we're just getting started. There's so much more to unpack about the implications of Tyagi's work.
Absolutely.
I can't wait. Stay tuned, listeners.
Yeah.
Because this deep dive is about to get even more fascinating.
It is. It's amazing to think how Tyagi's work might change the way we approach wind turbine design in the future. We talked about customized designs, but let's dig a little deeper into that.
Yes, let's. I'm really curious about how our model could influence where we actually put wind turbines. You mentioned coastal areas, mountains, even offshore. How would tailoring the design to those different locations actually work?
Okay. Well, imagine a wind turbine up on a mountain ridge. The winds there can be super powerful.
Yeah.
But also really turbulent and unpredictable.
Right.
So how would Tyagi's model help engineers design a turbine that can handle those conditions?
Yeah.
Well, her model lets engineers predict the exact forces hitting those blades at different spots along the ridge. And with this info, they can reinforce the structure, maybe tweak the blade shape, or even put in active control systems that respond to changes in the wind.
So it's about creating a smarter, more adaptable turbine that can really handle the unique challenges of that specific environment.
Exactly.
What about coastal areas? What unique challenges pop up there?
Coastal areas, they often have these strong, steady winds, which is, great for energy.
Yeah.
But you also have to deal with salt spray.
Oh, right.
Which can corrode the turbine over time.
Right. Salt water is notoriously harsh on anything metal.
It is.
So how would Tyagi's model help with that?
Well, her model lets engineers study how the wind carries those tiny saltwater droplets and how they impact different parts of the turbine. And with that knowledge, they can come up with coatings that are tougher, more resistant to corrosion, or even adjust the shape of the turbine to kind of minimize that impact.
So it's anticipating the problem and coming up with the solutions right from the get-go.
Yeah.
That's incredible. Now, what about offshore wind farms? Those just seem inherently more challenging. You're dealing with even stronger winds, waves, the corrosive nature of the seawater.
Right.
How does Tyagi's work apply in that kind of environment?
Offshore wind farms are they're a real frontier in renewable energy. They offer huge potential, but also, like you said, some big engineering challenges.
Yeah.
Tyagi's model is super helpful here because it gives us a much more precise understanding of the forces at play in that dynamic environment.
Can you give us some specific examples?
Sure. Imagine designing the base of the turbine to withstand the constant pounding of those waves.
Right.
Or creating blades that can capture energy from those powerful gusts, but are also flexible enough so they don't break in those really extreme winds. Tyaggi's model gives us the data we need to make those smart design choices.
So it's about taking all these complex factors, the wind, the waves, the salt,
Yeah.
and turning them into data points that engineers can use to build a safer, more efficient, and more durable offshore turbine. It sounds like we're moving towards a world where wind energy can be harnessed effectively, like almost anywhere.
Yeah, it's really exciting.
But beyond these specific, design applications,
Right.
there's a bigger question here, isn't there?
There is. Tyaggi's work isn't just about, tweaking individual turbines. It's about pushing the limits of what's possible with wind energy, on a larger scale.
Exactly. So if we zoom out a little bit and look at the big picture, what kind of future did Tyaggi's research point to? How will this impact the global energy landscape in the coming years, decades?
It's pretty amazing to think about it. I think we're really at the edge of a major shift in how we make and use energy.
Okay.
And as these wind turbines become, more efficient, more durable, more adaptable, their role in the global energy mix is definitely going to expand.
Okay, but how will that shift actually play out? What concrete changes can we expect to see?
Well, for one, I think we're going to see a lot more wind farms,
Okay.
both on land and offshore.
Okay.
And this means more energy independence for a lot of countries, reducing our dependence on those fossil fuels.
That's a huge step towards a more sustainable future.
Yeah.
What about the cost of energy? Will regular people, consumers, will they see any benefit there?
Absolutely. As we produce more wind energy and the technology keeps getting better, the cost of that wind power will probably continue to go down,
Okay.
making it an even more attractive option compared to fossil fuels, which will lead to lower energy bills for everyone.
So we're not just talking about, environmental benefits. We're talking about real economic benefits as well.
Exactly. It's a win-win.
Yeah, that's a powerful combination.
It is. And, beyond the economics and the environmental side of things, there are also social and geopolitical things to consider. As wind energy becomes, more important, it could actually reshape global power dynamics, maybe even lessening dependence on those regions with all those big fossil fuel reserves.
That's fascinating. So we're talking about a shift not just in energy sources,
Right.
but potentially in global power structures as well.
Yeah.
Tyaggi's work, it's started by focusing on the mechanics of these wind turbines,
Yeah.
but it could end up having ripple effects on a global scale.
It really could. It shows how, research that seems really specialized can have these huge consequences, sometimes in ways we can't even predict.
It's amazing to think that one person's work can have such a profound impact on the world. But let's not forget, there's the human element to consider here as well. How might Tyaggi's research impact, jobs and communities?
That's a great question. As the wind energy sector grows, it'll definitely create new jobs.
Right.
In manufacturing, installation, maintenance, research. And this could be really great for rural communities where a lot of these wind farms are located.
So we could see a revitalization of these communities driven by this, clean and sustainable industry.
Mm-hmm.
That's a really hopeful prospect.
Mm-hmm.
But, like with any big technological shift, there are going to be challenges.
Of course, yeah. The move to a wind-powered future won't be without its bumps in the road.
What are some of the key challenges that we might face?
Well, one big one is integrating wind energy into those existing power grids.
Right.
It can be tricky. Wind is an intermittent source of energy, meaning it's not always there like those fossil fuels. So we need to come up with better ways to store the energy from wind, so we can use it even when the wind isn't blowing.
Right. Like a giant battery for the whole power grid.
Exactly. There are some cool advancements in battery tech,
Mm-hmm.
but we still have a ways to go. Another challenge is actually moving the power from where it's made to where it's needed.
Right.
A lot of these wind farms are in remote spots far from the cities.
Yeah.
We'll need to invest in upgrading our transmission lines to carry that energy over those long distances.
So it's not just about making the energy, it's about getting it to where people actually use it?
Right.
That sounds like a huge undertaking.
It is, but it's essential if we're serious about this transition.
Yeah.
And then there's the issue of public perception.
Right.
Some people, they, worry about how the turbines look, the noise they might make, or their potential effects on wildlife.
Yeah, I've heard those concerns. How do we address those? How do we make sure that these wind energy projects are developed in a way that's sensitive to those concerns?
I think it's about talking to the communities early on, being open about the potential impacts and addressing those concerns in a thoughtful and respectful way.
Okay.
And we also need to, really highlight all the benefits of wind energy, not just for the environment, but for local economies too.
Right. It's about finding that balance, between promoting renewable energy and being mindful of the needs and the concerns of the people who live where these projects are.
Exactly. Finding solutions that work for everyone. In the end, the shift to a more wind-powered future is going to require, everyone working together.
Well said.
Yeah.
Now, as we kind of wrap up this part of the deep dive, I have to say I'm feeling really optimistic. Despite those challenges, the potential of wind energy it's undeniable. And with continued, innovation and collaboration, I think we can overcome those obstacles and build a brighter, more sustainable future for generations to come.
I agree. It's been fantastic exploring this topic with you and with our listeners.
It really has. And for those of you tuning in, we hope this has really sparked your curiosity about wind energy. Remember, stay curious, stay informed, and keep asking questions. Until next time, Deep Divers.
See you next time.
While we've been talking about all the amazing potential of Tyagi's work, I'm also thinking about the challenges, as we shift towards this more wind-powered future. Can't all be, smooth sailing.
Yeah, you're right. There are definitely some hurdles, some bumps in the road, even though the future of wind energy looks really bright.
So what are some of the biggest obstacles that you see up ahead?
Well, one of the main challenges is just the nature of wind itself. It comes and goes. It's intermittent. Unlike those steady fossil fuels, it's not always available exactly when we need it. And that can be tough when you're trying to fit wind power into those existing energy grids.
So it's not as easy as just, plugging in a bunch more wind turbines and flipping a switch, huh?
No, not quite. We have to find better ways to store the energy we get from the wind so we can tap into it even when the wind's not blowing. Like, think of it as a giant battery for the whole power grid.
Right, like a backup system.
Yeah.
So energy storage, that technology is key to making wind power more reliable, more consistent.
Exactly. And there's some pretty amazing progress being made with batteries, but we still have a long way to go. Another challenge is moving that wind power from, where it's produced to where it's actually needed. A lot of wind farms are out in remote areas, often pretty far from those big cities.
Right, out in the open where the wind is.
Exactly. And we need to invest in those transmission lines, to get that energy flowing efficiently over long distances.
So it's a two-part problem. It's not enough to just generate the energy. We also have to figure out how to get it to where people are.
Yeah.
That's a massive project.
It is, but it's something we have to tackle if we're really serious about this clean energy transition.
Okay.
And then, there's the whole issue of public acceptance.
Right.
Some folks, they worry about how wind turbines look. You know, they think they're an eyesore, or they're concerned about the noise or what it might do to birds and bats.
Yeah, those are valid concerns.
They are. And so it's really important to bring the community into the conversation. Right from the start, to be upfront about the potential impacts, to listen to people's worries and to address them, with respect. And we also need to make sure people understand all the good things about wind energy, not just for the planet, but also for those local economies.
Okay, so it's about finding that sweet spot, that balance between pushing for renewable energy and respecting the needs and the worries of the people who live in those areas where these projects are being built.
Absolutely. It's about finding solutions that work for everybody. Because at the end of the day, moving to a future powered by wind is going to take everyone working together.
I've got to say, as we wrap up this deep dive, I'm walking away feeling incredibly optimistic. Even with those challenges, the potential of wind energy it's just huge. And I truly believe that with innovation and collaboration, we can find our way through and create this brighter, more sustainable future for ourselves and for the generations that come after us.
I'm right there with you. It's been such a pleasure, getting to explore this with you and with our listeners.
It really has. And to everyone out there listening, we hope this deep dive has, really gotten you thinking about wind energy and its possibilities. Stay curious, keep learning, and don't be afraid to ask questions. Until next time, Deep Divers.